Mathematics 5, Quarter 3, Week 6. So we have here the competency, using different strategies, looking for a pattern, working backwards, etc., to solve for the unknown in simple equations involving one or more operations on whole numbers and fractions. So this is based on MELC with the code M5AL-3F-14. Let's have a background information. So when we say equation, it is a sentence in mathematics that contains an equal sign. The equal sign tells you that the expression on the left side is equivalent to the expression on the right side of the equation. When we say variable, this is the unknown value which is represented by any letter of the alphabet which may take on different values. While when we say constant, it is a fixed value. It does not change. And when we say solution of an equation, it is a number that makes the sentence true or equal. We have here a game. This is a mix and match. So we have here the mechanics of the games. The teacher distributes word cards to the learners. Number two, learners will read the word of the word card they are holding and must know the meaning of that word. And number three, if the teacher will say mix, the learners mix with each other. And when the teachers say match, learners find the opposite of the word they are holding. So what is the opposite of up? Okay, it is down. How about the opposite of white? Okay, it is black. How about add? Okay, subtract. And how about multiply? What is the opposite of multiply? Okay, divide. So let's have a review. Find the missing term in the following items. We have here number one, Sunday, Monday, Tuesday, Wednesday, blank, blank, and blank. All right, the missing terms are Thursday, Friday, and Saturday. So the rule is days of the week. Another problem, 5, 7, 9, 11, blank, blank, blank. What do you think are the missing numbers on the blank? So let's find out. The missing terms are 13, 15, and 17. So how did we get the 13, 15, and 17? So it says here rule is n plus 2. So 5 plus 2 equals 7. 7 plus 2 equals 9. 9 plus 2 equals 11. 11 plus 2 equals 13. 13 plus 2 equals 15. 15 plus 2 equals 17. So that is the solution. Let's take a look at the pictures. What can you say about the pictures? Okay, they are called patterns. And today, you will learn how to solve problems using pattern. Let's explore. The first week of Math Club had 3 pupils. The second week had 5 pupils, and the third week had 8 pupils, and the fourth had 12 pupils. If this pattern continues, how many pupils will be showing up for the 8th week? Let us identify what is asked in the problem. So the ask is total number of pupils to show up for the 8th week. And what are the numbers in the problems? They are 3, 5, 8, 12, etc. That is the pattern. So, are you a member in a math club? Why do you need to join in the different clubs in school? So, that is a bonus question for you to ponder. There are different ways of solving problems. One way is by looking for a pattern, and another way is by looking backwards. So, let's get back to the previous problems that we have read. The first week of math club had 3 pupils. The second week had 5 pupils, and the third week had 8 pupils, and the fourth had 12 pupils. If this pattern continues, how many pupils will be showing up for the fifth week? Let us analyze the pattern. So we have here week and the number of pupils. So week 1, 2, 3, 4, and 5, and the number of pupils, which is 3, 5, 8, 12, and the unknown. Let us find out what number should be placed here. So 3 plus 2 equals 5. 5 plus 3 equals 8. 8 plus 4 equals 12. 12 plus 5 equals, okay, 17. So there will be 17 pupils on the fifth week. Example number 2, we have here 3, 6, 12, 24, blank, blank, and blank. So the pattern is multiply by 2. 3 times 2 equals 6. 6 times 2 equals 12. 12 times 2 equals 24. 24 times 2 equals 48. 48 times 2 equals 96. 96 times 2 equals 192. Therefore, the next three terms of the sequence are 48, 96, and 192. Example number 3, we have here 2/3, 3/4, 4/5. What should be placed here? What is the pattern? So the numerators and the denominators are increasing by 1. So the next term is 5, 6. 2 plus 1 equals 3. 3 plus 1 equals 4. 4 plus 1 equals 5. As simple as that. Because the numerators and the denominators are increasing by 1. Let's have an example in working backwards. So each operation must be reversed to get back to the beginning. So the opposite of addition is subtraction and multiplication is division. Example number 1. N minus 7 equals 21. What should be the answer, or what should we place here in exchange of n? So let's reverse the operation. 21 plus 7 equals 28. So n is equals to 28. How about example number 2? N times 3 plus 1 equals 13. Let us reverse the equation. 13 minus 1 equals 12. Divide it by 3 equals 4. So the n is equals to 4. How about this one? Blank plus 2/3 equals 13 over 15. The solution is 13 over 15 minus 2/3 equals 1/5. So the answer here is 1/5. Let's try this. From his savings, Noel bought a pair of shoes for 650 pesos, then orders a cake for his mother's birthday for 560 pesos, and shared 175 pesos to his brother. If he has only 1,750 pesos, how much money was left? So the answer is 190 pesos. Always remember that we can use different strategies in solving for the unknown. One way is look for a pattern, and another way is working backwards. I have here an activity for you. So you have to solve for y in the equation. 5y minus 10 equals 5. Another is n minus 2 equals 8. And lastly, a number decreased by 20 equals 46. So another assessment for you. Nicole is writing a poem. She writes 6 words on the first line, 12 words on the second line, 24 words on the third line, and 48 words on the fourth line. If this pattern continues, how many words will there be in the fifth line? Lastly, in a mini theater, the first row has 8 seats, the second row has 10 seats, and the third row has 12 seats. If there are 20 rows in a theater, which row has 38 seats? Okay, so that's all for today, and I hope that you will answer the questions I had given you a while ago. Thank you very much.